This is the Insurance Institute for Business and Home Safety's Disaster Discussions podcast, where we explore the intersection of weather and the built environment. Hello and welcome to Disaster Discussions. I'm your host, Rachel Penton-Goche. Every summer, IBHS welcomes a diverse and talented group of interns and fellows from across the country to work closely with our world-class engineers, scientists, and communications professionals. The scope of their projects is wide, assisting with full-scale research, developing state-of-the-art instrumentation and electrical solutions, running lab equipment to conduct research, designing and constructing building systems, and much more. Most of the participants are students studying IT, engineering, meteorology, or communications in some form, spanning from undergraduates to postdocs. Some of these students even return to IBHS later in their careers. In part one of this podcast, we'll talk to some of those interns and fellows, and we'll catch up with the rest of the group in part two. So joining me today, first up, we have Craig Bowman and Thomas Dixon. Welcome to Disaster Discussions.
Thank you.
Thank you.
Okay, so Craig, I'll start with you. You are from the University of North Carolina, Charlotte, and you were an instrumentation intern. Both of you guys did a lot of stuff this summer. I got the chance to hear your presentations earlier today. Craig, tell me about some of the highlights. I guess I'll start off. Tell me a little bit about yourself first.
So my name is Craig. I go to the University of North Carolina at Charlotte. I'm majoring in mechanical engineering and physics with a minor in mathematics. I'm originally from Wilmington, North Carolina, so I've experienced a lot of weather disasters. And I'm really enjoying my time here so far.
Awesome. And Thomas, I'll let you introduce yourself as well.
Yeah, so I'm Thomas Dixon. I am an industrial engineer at Clemson University in my undergrad. Originally from Georgia, but I spent a little bit of time growing up down in Florida, in Pensacola, where we experienced some wildfires. So that's kind of what drew me to IBHS to start off with. But I've been the construction and operations intern for this summer.
Yeah, you also did a wide variety of projects as well. So I guess let me start off. Why did you guys decide to intern at IBHS? It's a pretty unique place to intern. You guys all did just like wildly different projects this summer. So what made you guys come to IBHS?
So my coach, Rafi, actually knows one of my professors, and I was recommended to Rafi. So that's how I got in contact with him. And I've also had a class with instrumentation. It was a very difficult class, but regardless, I enjoyed it, and I was a lot better at it than most of my peers, and very successful with that. So I decided, why not try it here? And I'm glad I did. Yeah,
you said you had a very valuable experience this summer.
Yes.
In your presentation earlier. Thomas, what about you? What made you choose IBHS?
So I was really looking for an internship that gets me a pretty broad scope of things to work on. Being an industrial engineer, you kind of have to be multiple disciplinary in order to solve a lot of the different problems that you're going to face in your career. And given I'm an Army ROTC, so I'm going to commission as an officer after my time in college. So given the time frame of how my summers look, I needed a really valuable internship that was going to get me exposed to a lot of different things at once. And so that's one of the reasons that I kind of chose IBHS. And then in addition to that, I really wanted to get some hands-on learning, both in the design field and also in the fabrication field. Like I said, just to kind of broaden my spectrum of things that I know and I understand. And so when I talked to Sean, he was really adamant about kind of gauging it towards my strengths, the things that I'm good at and the things that I understand, and also growing me at the same time. So that's probably the main reason that I chose IBHS. And then also getting to do work that is directly impactful to people's lives pretty immediately has been something really cool.
Yeah, I thought your projects this summer were really cool. I want you to talk about some of them, but one thing I noticed is, like you said, it really does have, you did stuff right here on campus that affects all of us every day. So that's something that's really interesting and really useful. I think these are like small things that actually make a huge difference. So tell me about some of your projects.
Yeah, so a lot of the things that I did work on this summer were more related to the campus than the research and experiments. But I got to work on the fabrication of a couple different things. I actually made 3 different sets of railings of different sizes and different varieties. So I got really familiarized with a lot of standards and codes from OSHA as far as hand railings and fall safety go. So that was something that was really interesting, kind of grew my strengths in my research. And so that was something really cool that I got to work on. And then as far as like the research sides of things, I have got to actually partner with a couple of the researchers and work on writing up some documentations of drawings and things for things that are actually going into the different experiments, specifically with the ADU burns. So I got to draw up different things and even got to create and design some things within certain parameters of their purpose that are actually going to go directly into research. That way they have the documentation, they have the materials list, they can do the math and figure out, how much of each material is burnt or is needed. And so that's been a pretty cool part.
Yeah, so you worked on the Ember catch wall. So for those listening, we have our wind-driven building-to-building fire spread experiments. There's a lot of embers flying around when that's happening, and we're studying a lot of different things. But as the embers blow up against the section of wall, they can burn the wall. So we're going to have various materials on this wall. Tell me a little bit more about it.
Yeah, so essentially we want to design a wall that kind of tests the strengths of a 6-inch non-combustible zone. So it's an 8-foot by 8-foot wall. On the left side, on one half of it, there's just all engineered wood siding, which is essentially just wood siding that kind of looks like shingles that cover the entirety. And then on the other side, it's wood siding all the way down to 6 inches from the bottom, where there is hardy board, which is like a concrete composite fiber board that is actually non-combustible. So the idea is we test, is 6 inches enough of a height or enough of a distance in a non-combustible zone to actually prevent that buildup of embers that are going to be blown against your building from catching it on fire? Or do we need to go bigger, or can we go smaller with that non-combustible zone? So it's kind of an addition to the projects that we're doing with the ADU burns, kind of almost a side experiment that we can check out. That doesn't require a whole lot of instrumentation or anything like that. It's kind of something we can just sit back and observe.
Yeah, and you also, so you say you helped design railings. I mean, you had to do all the research for the code, whether it was up to code or not up to code. You had to design what they were going to look like and what they were going to operate. And then you actually welded them too. Is that right?
Yeah. So I took a lot of the times, actually for all of the projects, I was just kind of handed hey, this is what we need. Can you help us figure out how to do it? So I partnered with our fabricator, with Tom Trout. He has years and years and years experience doing all sorts of different metal fabrication and work like that. And so I kind of came to him and I was like, hey, this is what we need. How do you think is the best way to make it work? And so the two of us kind of partnered on it. He would give a lot of ideas and then I would go back. I took the measurements of, the different spaces. For example, we have a mezzanine that we needed a new railing on. So I took the measurements and then I learned the constraints. We needed to put a gate on there so that way we could get pallets up on top of this mezzanine. Then I went and researched with OSHA compliance and then kind of came back and redesigned all the different things. So the gate actually slides under one of the other sections of rail. So I had to do, just a little bit of math and geometry and figuring out, all right, well, the gate needs to be at least 38 inches high, but the railing can't go over 45 inches. So we have, about 6 inches to play with on either side. And so kind of had to figure out, what parts am I going to use? What wheels are we going to utilize to get all the heights and everything right for that gate?
Yeah. So there's like a ton of work that goes into it. It sounds, it sounds seemingly simple. Oh, I'm going to build a hand railing, but there's actually a lot of work and research that goes into this.
Yes.
Yeah. Cool. So, and you were telling me you're studying industrial engineering, and I see some parallels. You said you guys do a little bit of everything. So it sounds like you also did a little bit of everything in your internship. So how does that all tie together?
So with industrial engineering, a lot of it that I've got to see from some of my peers who have gone out and graduated and also telling me about their internships within IE. A lot of it is problem solving and understanding what you can do. So a lot of the times industrial engineers also get roped into a lot of those code validations, making sure things are safe, but also the main goal of an industrial engineer is to create efficiency in whatever system. So going into the fabrication route, learning a lot about, what is capable, what can we do, that helps me to turn around and go into maybe a more industrial engineer's role. And now I have an understanding of, okay, well, if we need this fabricated, I know that that's something that is actually possible, and that it can even save us money and save us time, and that I won't have to contract out, another engineer to make these drawings and design these drawings. Even if I needed to, I could, go take the measurements, do the code research, and make these drawings for another system that I was doing in the future. And then I could either find someone to fabricate it in-house or send it out and get something created for us. So it kind of will help me to problem solve and also just to become more time adept in getting, different systems up and running, making them more efficient or anything like that.
Yeah, we do tons of problem solving at IBHS. And to me, one of the coolest parts about working here is that we're so self-sufficient and almost everything that we do is in-house with a huge range of skills. Everybody has completely different skills. So I guess that was kind of cool to see, right?
Yes, very much so.
Awesome. Well, Craig, I want to ask you about some of your projects as well. You also had a variety working with Rafi in the instrumentation department. What was your favorite thing you worked on this summer?
Probably my favorite thing had to have been the hail speed fork sensors. It was a big problem. What we were using before was a chronograph and radar gun, and both of those were very inaccurate for what we were trying to apply it to. There was so much variance in it, like the size and if the hailstone was clear, based on if it was molded or not. That could impact the speed measurement we were reading. And I really like this project because it's really going to impact the hail research here, because without it, we would have very inaccurate readings, and that can mess up everything as far as the research goes. But I've really enjoyed it, and it's kept me very busy.
Yeah. So for those who don't know, we shoot hailstones out of this. It's the hail cannon you're referring to. Okay, so the hail cannon in the hail lab, we shoot these hailstones at different roofing materials, and that's part of our research. So, what do you think you helped? You mentioned a little bit, but how do you think we're going to really see things improved in the hail lab going forward with our research?
So we'll start getting consistent numbers. Before it was jumping up and down from what the speed was. And then that also affects the kinetic energy. So it just, before it wasn't as accurate, leading to maybe wrong advice. I don't know. But
yeah, accuracy is definitely important when we're talking about science, for sure. What about some of your other projects? I know you did some other ones as well.
So I've really been around. I've talked with everyone around campus, helped as much as I could. Another project directly relating to instrumentation would be for Ali's project with the Parsifal sensor. Before, we haven't used it before, especially in the coding language that we were using, CR Basic. And I was just basically approached one day by Ali and said, "Hey, Rafi said that you're kind of smart. Do you mind trying this?" And I got it working. I was using a unique software and hardware I'd never used before, Campbell Scientific and CR Basic. So yeah, I really enjoyed that. I love learning. I love just always doing something, keeping myself busy.
So what do you guys both hope to do for careers? You talked a little bit about what you'd like to do, Thomas, but what do you guys envision for your future career, and how do you think things that you've worked on here at IBHS, or skills, or really anything you've learned here this summer, how do you think those would help you in your future careers?
So for me, I haven't really done anything with electrical as much. I mean, I have, but not to this extent. I've really learned everything to do with connections, sensors, and everything. And that's something that's really lacking in my course load at school. Something we need to do, but we just don't have time to in undergrad. But it's really applicable for everywhere. Everywhere you go, you're going to work with sensors and electrical, because in mechanical systems, they always work with electrical systems nowadays. And as far as careers go, it really just depends on where I end up, the events that lead up to where I land. But
yeah. Awesome. And you got a little taste of weather this summer as well, right? You said you hadn't dealt much with weather previously in meteorology.
I've never dealt with weather, never considered going anywhere close to weather, being a mechanical engineer. But I learned how cool it is and how much science is behind it. And there's a lot with being a physics major also that relates directly to everything weather. And I would have never imagined coming to IBHS working with weather, but I'm really glad I did.
Yeah, we're all about weather here, weather hazards in particular. Thomas, what about you?
I've always said, it's kind of completely opposite direction that Craig's going, but I've always said that my dream job is somewhere in motorsports, specifically in motorsports logistics or team management. And so getting to work here and see, the 7 and 8 different departments all coming together between instrumentation, carpentry, fabrication, research, and everything else that kind of comes together. Getting to look a little bit on the project management side of things throughout my internship has really given me a good grasp and a good gauge of understanding just how better to mesh multiple different systems, which is a lot of the time what's happening in motorsports teams. You have your logistics guys, you have your mechanics, you have your electrical, you have your engineers, you have your researchers, and everything in between. So just kind of learning and seeing a lot of how the different things mesh. And as well as I talked about before, efficiencies, just trying to find the most efficient way to do things, the most cost-effective ways to do things. That's something that I got exposed to a little bit here this summer. And so kind of just seeing, like I was talking about earlier, just getting the most vast scope of things that I can learn within, a 10-week period of being here over the summer. I think that will definitely arm me and make me a better candidate than maybe somebody who did not have this internship or something of the sort going into future and hopefully a professional career in motorsport.
Awesome. Well, you guys both jam-packed a lot into this summer. So thanks for interning at IBHS and thanks for joining Disaster Discussions today.
Thank you.
Fortified Fred here. At IBHS, we've spent more than a decade studying the damage caused by hurricanes, tornadoes, high winds, and hail. We identified the common weaknesses in homes built using conventional construction standards and spent years researching the best solutions by putting them to the test at our research center. Now, you can use our science to defend your home or business simply by asking your builder or contractor to follow the Fortified Construction Standard to protect your home when severe weather strikes, keeping the roof on and the rain out. Visit fortifiedhome.org to learn more.
Joining us on the podcast now, Ankush, our wildfire experimental research intern. Welcome to the podcast.
Thank you.
Okay, so you had a pretty cool internship, I would say.
Yes.
So when you're describing this to your friends and family, are you going to say, yeah, I spent my summer setting hot tubs on fire?
Yes, honestly, some of them won't believe me that I'm actually lighting up a hot tub on fire and testing out it. So it's really this is an entirely new experience for me, as in being a mechanical engineer and working on a wildfire department. It's an absolutely a different path, but I did enjoy this as adding on new experience to my CV or to my life as well. So I can have something to say that I was a mechanical engineer as well as I worked or contributed something towards wildfire department as well.
Yeah, that's awesome. So you're studying engineering at Virginia Tech. Had you had any exposure to wildfire at all before coming to IBHS?
Actually, I never had any experience to wildfire, but I belong from India, and in India, I belong from Mumbai. We do tend to face heavy rains during monsoon season, so I have experienced some sort of weather, but not dealt with in depth how we dealt over here in this facility right here.
Yeah. So you have experience with the monsoon, but no wildfire.
No.
Well, did you choose this topic? How did you come about settling on researching hot tubs? You may be the only person in the world that's setting hot tubs on fire for an internship. I don't know, but how did you come to this decision?
Well, it has a unique story. So I was eventually deciding to go for an internship for some, and I was filling out tons of applications, like how a normal student or any person will do it. So I was just randomly scrolling through the positions that we have for internship, and I just came across with wildfire research into. So I thought, I haven't seen this before. I should click on it and read out the job description and let's see where it goes. And here we are.
Here we are.
Yeah, that's how it's out.
Okay, so for those who are not familiar, obviously we do a lot of wildfire research at IBHS. A really, hot topic, for lack of a better word, are hot tubs. And one of the reasons why is because in the Los Angeles fires recently and other previous fires, we've seen hot tubs burning down, especially serving as connective fuels when they're located close to houses. We need to learn more about hot tubs. So you performed some tests this summer to help learn more about hot bathtubs and how they do or don't burn. So kind of just give me the general rundown of what you were hoping to learn this summer.
So one thing I got to learn about this research topic is that, first of all, how a typical setting over here is like there's a big house, and right next to it, within zone 0, that is like 0 to 5 feet, a hot tub is situated, which is a very gigantic mass of plastic. Like, if this thing burns, this thing will burn for a prolonged duration, since it has a lot of convective fuels like plastic, wooden composite, wooden structure, then acrylic mold. That's a mold wherein people sit in and have fun in hot tub. That's the major contribution to this ignition that happens during wildfire. And once this is set on fire, you cannot suppress it. Like, it's not that easy, since I had conducted few experiments and